personal, I'm not recording it. Okay, so we'll start with alkanes, the structure of alkanes. And we'll go through alkanes, alkenes, alcohols, and then carboxylic acids. That's a lot of work. So I'm going to try not to talk for too long because we've done a lot of this. So alkanes, and just to recap, carbon makes 4 bonds, hydrogen makes 1 bond, and something that is now new since we did alcohols. Oh, what's that? Well, that's interesting. Oh, carbon makes 4 bonds, hydrogen makes one bond, hydrogen makes 1 bond, and alongside that, oxygen makes 2 bonds. Okay, so that's something that we kind of did last session, but not really, and it was done quite easily in terms of how we draw alcohols. But let's dive straight into it. The other thing I'm going to write on here is me PB. And me PB, let's put some spaces in. Spacey, PPB. And me PB is a way for me to remember how many carbons you got. So 1, 2, let's move that forward a bit. 2, 3, 4 carbons. Okay. Let's just stretch that out a bit. And let's just reduce the space there. That should make it nice and easy. All right. And M stands for meth, eth, prop, and bute. Now, I'm not going to go through that. You've got it in your notes somewhere on this board. The smallest of alkanes is 1 carbon. 1, 2, 3, 4 bonds. Hydrogen, 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 hydrogen. This is an alkane. It has no double bonds, no functional groups to speak of. It is 1 carbon, so it's M. This is methane. Those are the alkanes. They're pretty straightforward. We then head into alkenes. Alkenes are called alkenes because they have 1, and that's really important, 1 double bond. The smallest alkene is 2 carbons. Carbon, carbon, dash, dash, hydrogen, hydrogen, dash, hydrogen, hydrogen. Right, just remember to count to 4. That sounds really weird. I've got year 13s, and even I, when I was in Augo last week, I had 1 carbon with 5 bonds on because it happens. You just don't pay attention. All right, I was correcting someone's work, and I looked at it, I'm thinking, why is this hydrogen not adding up? And it's because we had 1 carbon with 5 bonds on it, and you just sometimes don't count. So this is an alkene. Going back to alkanes, and I'm just going to change from alkanes. I'm going to go to alcohols. Alcohols. An alcohol has what we call an OH group. OH group. Right. Now, the smallest of alcohols is 1 carbon. See, with all my bonds. Let's pop an OH, and we're going to do a proper OH like this, and that'll be a HHH. This is 1 OH, and alcohol has 1 OH group. This is 1 carbon, 1 is M. This is methanol. Methanol, right? That's not a capital letter, I've put it there. So you can see how I've named it. We did this last week. So we've got alkanes, alkenes, alcohols. Now, the new one that I'm going to throw in here, we've got a MEPB down there. Let's just get rid of that. The new one, if you get that far, right, and I wouldn't see the structures drawn. I don't care if they're right or wrong. And I'm very lucky. I teach year 7. Year 7 has just come out of primary school, and the nice thing about year 7 is they just do stuff. I'm like, dudes, try this. Like, oh, okay. So let's have a look at something really horrible. It's called carboxylic acid. I don't mind if you get this far, and the reason I think carboxylic acids are horrible, I'm going to break them off from alcohols, is that they look strange. It was something I was trying to explain this morning to my wife because she's her background's economics and not science. and we were looking at the difference. She was looking at citric acid and saying, look, how is it different from something like, hydrochloric acid? And structure is very, very unusual. But after you do it for a while, it becomes quite straightforward. So I'm going to start off with one carbon. The functional group looks like this: double bond or single bond or H. This is the functional group. This is what a carboxylic acid looks like. So 1, 2, 3. The simplest of carboxylic acids would have a hydrogen here. This is one carbon. M for meth. This is meth. Ethanoic acid. All right. So again, there's no space there. There's no capital letter there, but I've put that there so you can see how I'm naming it: methanoic acid. Now, there's a carboxylic acid that we actually like on our fish and chips: vinegar. Right. Now, that has the same functional group. So watch how I draw. Instead of one carbon, it has two carbons bond out, C, and this is covered in H's. This is two carbons, so it starts with F. Go back to me, PB. Two carbons is E. That stands for F. Ethanoic acid. All right. So what I want you to do today is draw 4 of each. So I'm going to put it down here. Okay. That's it. T. I want you to draw. Let's make this big. Let's change text color to something I like pink. Draw 4. Oh, that's the dollar sign. 4 of each. No, I want 5. Let's see number 5. 5 of each and name them. So that's your task for today, right? So I've gone through alkanes. You saw methane. You saw ethene. Did I put ethene's name on there? I haven't. This is a double bond. Alkenes have one double bond. This is 2 carbons. 2 is E. So this is ethene. Let's put it there. Ethene. Oh, that comes out in pink. That's really nice. Let's do the ene in capital so you can see how I've added it on. This is all work that we've already done. All right. This is methanol. Already done that last week. These are the ones that you haven't done before. All right. So the entire session today is draw, draw, draw.